Hello, guys. Hello, the early comings. Hello, David. Hello, Peter. You arrived a bit early, so we have time. We let other people to join also. We were a bit earlier. We'll start in 15 minutes approx. Oh, hello, Yarden. How are you?
Hey, Lior, how are you?
Fine, fine. Thank you. Thank you for joining.
I'm here to hear Moshe Ferber. Moshe Ferber, my favorite.
Of course, of course. You came a bit earlier. We'll start in 15 minutes. Yes, we'll start at 5 p.m. Israel time.
Okay.
So
Thank
bear
you.
with us. Can you see my screen?
Yes.
Is it visible? Okay, great. Great. Thank you for that. Okay, so stay tuned. We will start in 15 minutes.
Okay.
Bear with us. Okay. Hello, Varma. Hello, Peter. Hello, Dean. You came a bit earlier. We'll start in 15 minutes. Okay, so bear with us. Hello all, thank you for joining. We'll start in 10 minutes, so please bear with us. Hello all. Hello all. Thank you for joining. Please bear with us. We have 8 minutes and then we will start. We have a very interesting panelist today, very interesting lectures. So please bear with us. Start in a few minutes.
ליאור, מה קורה?
מה שלומך?
הכל מעולה, תודה רבה, מה שלומך אתה?
מעולה. בסדר גמור. יש לנו כבר, we have 9 people. We are still waiting. We'll start, of course, in a few minutes. So let's switch to English. Moshe, you can see my screen?
Yeah, definitely.
Okay, great. Okay, guys, so we will start in a few minutes. Please bear with us.
They can hear us now, the participants?
Of course, all can hear us. Peter, also say hi.
Hey, Peter, good to see you.
Hey, Moshe, it's nice to see you.
Hey, Alex.
I think it's Yarden from Deloitte.
Okay, I'm
But
sorry.
also Alex here.
I heard a voice and
Yeah.
and somebody wrote something. Then you're also here. Great.
Yeah, I'm here.
Okay. What else do I need to get prepared? So you guys can hear me well? Is my mic?
Yes, we can.
Yeah.
Yes, we can. So we plan very interesting. What, Moshe? You want to ask something?
Yeah, you don't see my video?
Yes, I can.
I
can see your video cam. So we prepared very interesting lectures today. Lots of interesting people, the interesting topic, very technical, with a demo also, a real demo in the end regarding key management in microservices. So guys, please bear with us. We'll start in 5 minutes. Of course, everything is recorded, so you will be able to see it also after the meetup. All the materials will be uploaded to our meetup group, of course, and all the presentation also. So start in a few minutes. Hello, Jeremy.
מה נשמע?
Fine, thank you.
Can you send to Ori another a link, because his link isn't working properly, he said.
Oh, okay. Let me paste it here. I've sent it, Jeremy, in the chat.
Okay, that's Ori's link.
That's the link. That's the link.
Okay. All right.
Hello, Naor.
Hi everyone, apologies for the delay.
Guten Morgen.
We operating
Okay.
on time.
How is it in London? Is it raining now?
Actually, today it's super hot, but it's like 17, 18 degrees, which I know it's funny to say that it's super hot when you're probably like sitting in an air conditioning where everyone are like 27 degrees in Tel Aviv or in the area. But no rain today. Maybe tomorrow. I think that the week should be rainy. So
Always raining in England.
always raining in England. That's a fact.
Yes. So we have 19 people joined, and hopefully more will come. We have 2 minutes, guys, so please bear with us. We have very interesting lectures, very interesting topics with a demo that we will present, a technical regarding secret management. So it will be very interesting. Please bear with us a few more minutes, and then we will start. Thank you all for coming. So please bear with us with a few minutes, and then we will start. Hello, Kobe. Thanks for joining. Hello, guys. Thanks all for joining. We'll start in a few minutes. Hello all. Can you hear me? Moshe?
Definitely can hear you.
Okay, so I can see people. Wow, Alex. Okay. So we already have some requests from Alex Peleg. So great. I can see that people are excited and we have lots of people online, almost 60 people, guys, 60 people. Wow. Guys, thank you all for joining our application security meetup regarding cloud security and best practices. We had lots of very interesting lectures today with Oded, the CEO of Akeyless, Moshe Ferber, also from CSA Israel, Naor Penso from FICO, and Ori, also who is the VP R&D of Akeyless, with very interesting lectures today about application security, cloud security, key management, secrets in Kubernetes. So it's very interesting topics. Hopefully you will enjoy it as I am. And without further ado, I do want to invite Oded, who is the CEO and the co-founder of Akeyless. He's a veteran of the IDF. I don't know if he can elaborate on what he did in the IDF, but he's very interesting person. I can tell you for sure, he has a lot of secrets that he will not tell you. However, he will tell you about how to secure keys and strong cloud security. So Oded, the stage is all yours.
Thank you very much, Lior. Pleasure to be here today. Thank you all. I'm also expecting to see all other members in this panel. Great event. And yeah, let's start. By the way, Lior, for a question, there are secrets, and like the famous way, there are secrets that I know and I'll need to kill you. But the best way, by the way, to protect a secret is actually to forget it. So yeah, but we'll talk about that. That's for sure. So hi, everyone. Today, my name is Oded. I'm the CEO and the co-founder of Akeyless, the workload identity orchestration platform. I would explain exactly what are we talking about, but today I'm going to speak about the key to strong cloud security, about my background 20 years ago as a captain in the Israeli Defense Forces with the cybersecurity. Lots to do with security infrastructure back in the on-prem, as well as the new cloud operation with all the processes from development to product to operations. So I kind of saw a few, and also I had some with the B2C world and not just the B2B. Anyway, let's start from now. Lior, do I have the ability to run all the slides?
Yes,
Okay.
yes. You have permission?
Okay, so I'll click. Yeah, okay. So first of all, just a few sentences about Akeyless, no more than this, and then we'll go straight ahead to what we wanted to discuss today. But just for you to know, as I presented myself, the CEO and the co-founder of Akeyless, we're a unified CSA identity and access management platform that provides several use cases on top of one platform. One is the classic secrets management. The other one is secure remote access in the realm of zero trust privileged access. And number 3, data protection with key management all across KMSs and data protection over KMIP, multi-cloud KMS, tokenization, encryption as a service, and so on. We're providing service basically for a number of market leaders in several sectors such as pharma, software, ad tech, online e-commerce, and gaming, as you can see in front of you. We're holding a patented technology to manage encryption keys on a non-trusted distributed environment such as the cloud. It's called Akeyless DFC, virtual HSM. Very unique, and we can later on talk about that. We are providing a global available SaaS all around the world that provides a unique, as I've mentioned, secrets management as a service, secure remote access as a service, and data protection as a service. We're SOC 2 Type 2, FIPS validated, and ISO 27001. That's it for about Akeyless. And let's go straight ahead to speak about I see that, yeah, okay, of course. Let me just close this. Okay, so let's first today, when we speak about the key for managing cloud security, the key component for cloud security, I would like to focus my sayings today specifically around the challenges of DevOps and cloud era. And let's just, in general, let's first see where is it that we're that we're here, right? What are the characteristics? What are the challenges that we're now facing? So first of all, with the cloud, DevOps environment and the new Kubernetes and containers, we're talking about having ephemeral resources, right? There's automation, there's infrastructure as code, obviously, but basically resources go up, go down, and that's the difference between what we used to have in the fixed environment, and we have lots of more of those resources, right? We have multiple environments. We have sometimes multi-region. We have the hybrid environment. We have the on-prem, and then we're opening another environment. This complicates things even better because even more because we need to suddenly authenticate cross hybrid environment, and we don't have exactly the same IAM, right? We have the AWS IAM, and internally, actually for workloads, we don't really have an IAM internally in the on-prem. There is no identity and access management for the on-prem machines, and there are all kinds of other challenges around, there is no perimeter around the on-prem, all of those cliches that we all know about, that basically we have more and more environments. There is no one clear segment of the organization, rather than all kinds of islands and you might say small clouds out there, that the data of the organization is actually spread between all of those places. Now, one of the another challenges when we speak about the world of where we are not managing our own infrastructure is actually, how do you find the root of trust? Okay, the classic HSM, how do a secured module? Basically, how do you keep encryption keys, right? Privileged access, in which how do you provide remote access for those kind of environments? But this is just to start and speak about the challenges that we're having, and I'll go even deeper than that. But in short, as you can see in front of you, we are now in an era and entering an era. Some of you in this talk are already very much aware of this chaos, identity and access management chaos in which we are at, and some of you are about to enter it in the next following months and years. But basically, with all of our environments, we have what is called secrets. Those secrets can be passwords, SSH keys, API keys, certificates, both PKI and SSH certificates, SQL credentials, RSA signing keys to sign certificates and to sign transactions. We have encryption keys. And with all of those, we have multiple of those different tools that are currently managing those kind of credentials and encryption keys and certificates. But for some of us, there are no those tools. And there are all kinds of difficulties with those tools, and I'll speak about that later on. But basically, at the last 5, 4, 6 years, in the last years, basically, there were all kinds of trends that increased the number of those secrets. Number one trend is about containerization, right? The break of the monolith. Now we have lots of more components. There is actually now more components, machine servers than employees, right? 10 years ago, 20 years ago, you've had more employees than machines, and today we have more machines than employees inside an organization. So suddenly we have lots of those components that need to communicate with each other. There's the DevOps movement, automation. Basically, machines need to create other machines, and zero trust, obviously, where it means that every component in the network needs to be authenticated. All of those trends that I've just named are actually the background of why is it that we're currently seeing more and more of those secrets objects that tend to leak, obviously. So in terms of facing the challenge of the new realm, of the new era of cloud and hybrid cloud, and what is it that we need to do and start to mitigate the problem, right? So I'll now wish to go more deep into the problems and things that I'm guessing that all of us have began to see, questions like who can access my data, obviously, but more importantly, how can I validate a certain identity? There are all kinds of solutions out there. And I've mentioned, for example, validation of identities like AWS IAM for machines. There's also validation for identities by humans, which is Okta, XAML-based, Azure AD, basically human-based identity providers, and data encryption. Right? How do I protect my data is with the encryption. Where do I put my key? That's a question within the cloud. I'll talk about that later on. But is it how to validate the identity of the one that actually wishes to encrypt or decrypt the data, right? If there's any component inside my network that wishes to decrypt the data, how would I authenticate that particular identity and make sure that no one steals that identity, right? So are all kind of those questions lately that becomes more and more severe again in a distributed environment such as the cloud. Now, the challenge or the step to mitigation number 2 would be around, as I've mentioned, identity validation. And let's go even deeper to that. We're talking about 2 types of identities today with humans and machines, as I've mentioned. Now, they're using, as I mentioned at the beginning, a numerous types of different secrets, right? Credentials and passwords and API keys and certificates and SSH keys to get into, and all of them are just out there. And the problem is that, even if you're using data protection, you're using data encryption, eventually if someone is grabbing your API key and it finds that secret specifically that you were using in order to decrypt the data, then basically that encryption doesn't worth anything, isn't it? So it's all about the ability to validate the identity in a good way, in a good manner, with the good tools. So after validating the identity and after protecting the data with encryption keys, now there's a question of who is allowed to actually go into my database, to my non-structured data, where they are obviously the users of the application. They are the regular users, not necessarily the privileged ones. And then there are all my developers, DevOps engineers, DBAs, IT architects, all of those that actually require what we call a privileged access. Okay, that privileged access is basically the administrator of the Linux server, of the Kubernetes cluster, or the administrator of the database. And well, it is obviously relatively known that with those privileged access, you would need, according to regulation and compliance, depending on the size of the organization, but basically you are obliged to actually audit all of those actions that privileged access are doing, are making, or operating within your entire environment, where session recording is needed, and you need to keep on those secrets obviously safe without revealing them to the administrator itself, to keep rotating those passwords. There's all kind of those challenges that you need to make sure. But you know what? The new thing, as I've mentioned earlier, is that the privileged access management is no longer just a question of humans. Now, because of automation that have become more and more widely used in the last few years, machines were actually the ones to create the majority of privileged access. Because again, automation, it means that servers need to create other servers. Machine creates machines, and they have all kinds of privileges, obviously, in order to perform those actions. Another challenge in the realm of root of trust, I just touched it at the beginning, but now let's ask the hard questions. How is it that you can use encryption keys within the cloud? You're not running your own hardware. And that basically means that even if you are saving, you're protecting, you're storing your encryption keys within a cloud HSM, cloud hardware secured module, which is known to be the most secure way, or relatively the most secure way to keep and store encryption keys. How is it that you are not actually the one to run your infrastructure, you're not actually the one to run your own hardware? How can you make sure that you are the exclusive owner of your encryption keys, right? This is a major problem within the cloud environment, as well as all the other ones that I've just named, right? So there are all kinds of places to keep your encryption keys, but today going towards KMSs, key management systems, and HSMs, this is the considered way. But again, there is like a contradiction when you're speaking about the cloud. You're not running your own hardware secured modules. AWS or GCP or Azure are running your hardware secured modules. And how can you make sure that you're protected even from them, from supply chain attack, from insider threats, and so on and so forth? More than this, there's a problem of authenticating, where actually in order to authenticate to your HSM, let's speak for a minute about the on-prem HSM, you actually need to authenticate to that HSM with an API key or with such kind of a password or whatever. And this is the whole story of what is called secret zero, right? In order to get to my encryption keys, I need to have a password. And as I've mentioned earlier, if my password is being revealed somehow and compromised, then it doesn't really matter that my encryption key is actually kept within a hardware box, because if someone grabbed that password, then they are being able to decrypt the data that I'm saving in such great efforts. So this is the problem of the chicken and the egg, right? The secret zero. I need a secret in order to get access to my more important secret, and that needs to be solved. So I just named all kind of, a very, you might say, a large list of different types of new challenges in the cloud. But actually, what we also find, and I think one of the most challenging parts within the new way that we're coding our application, the new way that we're using development, the automation, the DevOps environments, and the new workload platforms is actually the fact that all of our secrets are currently sprawled away. We see those secrets within the source code. We see them on GitHub, on GitLab. We see them quite often within configuration files and DevOps scripts. We find them within infrastructure as code. Tools like Quali, Pulumi, and also obviously Terraform. So you see all of those different secrets and credentials within those scripts actually. And you find them also within the Kubernetes clusters, within the images, within Jenkins, CI/CD, within configuration management tools like Chef Puppet and so on. Secrets, basically credentials, certificates, keys, all of them are sprawled away the environment, and then they need to have some kind of a home that would keep them, like a store that would keep them in a very secured manner and would be able to share or to inject and provision those secrets only when they are needed. So to keep it completely clean, to keep your source code completely clean out of those secrets and credentials, so that no one would be able to grab them, no one would be able to have access to those secrets, to keep your DevOps scripts completely clean from those passwords and API keys. And if that's not all, to keep your workload management platforms for CI/CD, configuration management and provisioning and orchestration, to make all of them very much clean out of those secrets, credentials, as I've mentioned. Just checking up to see if there are any questions before I'll proceed. So I see here questions. Well, Lior, would you better if you wait to the end of the session?
Actually, depends on you. I think it's a general question, so we can answer in the end of the presentation.
Okay. Is it about the KMS shift to KMS to HSMs?
Yes, yes.
Okay, so very quickly, just to provide some context, the shift between key management system to HSM is actually at the level of compliance that you require, the level of security, if you wish. Because some cases you can satisfy with key management systems. Take in mind that HSM, hardware secured models, is not necessarily the one to manage the whole key lifecycle management, rather than just being the storage of hardware secure of the key itself. So anyway, you need to have them combined, generally speaking. So let's that put aside. If you'd like, I'll be happy to provide more information about those. So a bit information about workload identities. So I've named all kinds of challenges in the last few minutes that are actually, by Gartner, are named in the roof term, named workload identities, as you can see here in the title. Now, workload identities include a full set of tools that are in charge to manage certificates, credentials, and keys obviously in IT environment, engineering environment, DevOps, cloud environment. But as you'll be able to see, and not to speak about secrets management specifically, let's talk about the peripheral solutions right now. So everything starts from the root of trust, from that key management and HSM technologies that basically hold those encryption keys. Those encryption keys are being used then in order to sign certificates, for instance, right? You have your own internal certificates within the environment. There are tools that provide those. Basically, you can find Thales for HSM and key management. You can find Venafi and Key Factor for certificate management. You can find many others that provide also PAM and SSH management. And all of those are providing some kind of a particular subset of capabilities that would provide some kind of solution to the problem of the secrets. How can I protect the secrets? Oh, for certain use case, I can use the certificate management platform. How do I protect my encryption keys? For some of my use cases, I would be able to use key management and HSM. How would I protect my human credentials, I'll be able to use privileged access management and so on. The problem is, as it goes from that report, and for that, take the analyst's words for that, and you don't need to use mine, but basically this is how it is being explained also in this report. All of those use cases that are still valid in the new world actually do not get new answer with the tools that were created for the past world. So if PAM was created around 20, 15 years ago, and how the secured models kind of the same, you'll find those tools, for instance, not to support the ephemeral nature of the new environments, right? So for instance, scaling, okay? Hardware secured model is in hardware, right? So if you need to have suddenly auto-scaled software facilities, auto-scaled containers, you are basically limited by the hardware that you're having, okay, in terms of number of transactions. In cases of connectivity and the way to work with tools, there are all kinds of certificate management and PAM tools that we should work with. And well, generally speaking, the API and the SDKs that those kind of services provide are not just easy as we are now used to work with APIs and SDKs, because everything is API driven, right? So it has to do with the philosophy of those products that were designed basically for the fixed environment, for a low number of environments. They are not necessarily thinking about multiple environments and hybrid access, right? For instance, PAM, you need to use a separated solution for secure remote access to get access to your environment, and then to use the privileged access to record your sessions. There are all kinds of those problems within the current tools. And it turns out that the new way to manage those secrets, certificates, credentials, encryption keys for the DevOps and cloud environment is actually called secrets management, okay? So this is in front of you. This is what Gartner have talked about. By the way, very interesting report. If you'd like, just approach me on offline. I'll be happy to provide you a sneak peek to that report that was published a year ago. So secrets management, generally speaking, is about fetching the credential, with the ability to fetch credentials, to store credentials, to dynamically create credentials, certificates, also to sign certificates on the fly, SSH, TLS certificates, basically to manage all of those types of secrets, all of those types of objects that I've explained about in this lecture, and to do so to any type of identity, basically, both for machines as well as for humans, right? Some secrets or some use cases would be provided according to secrets management tools, and some would be provided with some extension and enhancement of the secrets management platform. But basically, think of the fact that when you have here a human or application, they would require the ability to fetch those secrets on runtime, because they would not have it locally. That's the whole point, right? To protect those secrets, to protect those credentials, and then those secrets will be decrypted on runtime or signed on runtime and then provided to the resources themselves. So this is how this works in terms of secrets management. It's about obviously the plugins and authentication. I'll talk about that in a minute. Let's check a little bit about the questions. I'm eager to answer your question as we go. Regarding the Gartner report. So again, talk to me on offline. I'll have my email presented for you, but also you'll be able to, let's be in touch. So I'll provide it to you. What would be, Nikita asked, what would be the differences between secrets management and KMS? So KMS is specifically for keys, specifically for encryption keys. With KMS, you would not find the ability to actually protect or to create for instance, dynamic secrets, just-in-time secrets. You would not be able to create SQL credentials by using KMS. That's the whole thing. With secrets management, you're enjoying a Swiss Army knife of all of those capabilities. With KMS, you're basically having the ability to keep your encryption keys and to rotate them. But what about certificates? So again, secrets management would have all of those use cases all together and wrapped and ready to be used by the DevOps engineer or the DevSecOps architects. Next question by Amit. How does an application authenticate to the secrets management system to fetch a secret? Does it need a secret for that? That's the problem of secret zero. And I'll answer that right immediately, although I've mentioned that. But I'll repeat on that because this is exactly what I'm about to say. Thank you, Amit, for that question. Stay tuned within a minute. And
there is a question. There is
What?
a question here. There is a question in the QA by Nikita. So can encryption keys can be stored in an open source tool such as KeePass with a database stored and on OneDrive?
Can encryption key be stored on? So with can be stored on those kind of places. So it can. Is it considered to be secured? Definitely not. Encryption keys need to be managed within KMSs as a start, or an equivalent solution for secrets management that would be able to store those keys in a FIPS level integration. FIPS is the highest certification for cryptographic keys management and cryptography by the US NIST. So you'll need to keep encryption keys either within secrets management or key management systems, either the cloud ones, either the self-deployed ones. Obviously, with Akeyless, if you would like, you can go to our website and look at it. But basically, we are not recommending on keeping encryption keys on anything besides those solutions. Okay. Okay, so let's go further and speak about the authentication, right? So with secrets management system, that would be basically providing you the ability to keep encryption keys, keep credentials, sign certificates, and so on. You would have to have within the new cloud environment the ability to integrate with many of those platforms, right? So secrets management basically means that you would need obviously SDKs, so you would be able to add it to your application. So your application would be able to fetch secrets directly within the code or within your scripts. CLI, obviously, to again integrate the secrets management to be able to fetch those secrets within those different scripts. And plugins, let's say plugin for Jenkins, for instance, right? You need within your Jenkins jobs, you need to have all kind of credentials, right? So instead of having it statically mentioned within those jobs, you would be able to just automatically fetch them, and the plugin of Jenkins would be able to fetch those kind of credentials directly from your secrets management system. And the same go with Kubernetes. You would be able to declare those kind of credentials that you wish to fetch, to declare them on the YAML file, and automatically the sidecar, the plugin of that secrets management solution, will be able to inject and provision those secrets directly to your containers. The whole thing, by the way, the whole idea behind it is not to have images include credentials, certificates within them, right? The whole point that if someone finds your image, they would not see any secret within it. It's a very important thing. It's very bad practice to have credentials, certificates within it. Okay, I'm seeing another thing around the Gartner report. So we would not share it publicly, but we would be happy to have I'll be happy to have a conversation and a meeting and to be able to share with you some of it. So again, if you're interested, please point us out and just connect with us, connect with me in offline, and I would be able to find the way to provide you the information that you need within that report. So this is just the way to communicate with the secrets management system. Now, the way to authenticate to the secrets management system is exactly either using human authentication or machine authentication. So let's go first for the human authentication. It's far more easy to explain. You have XAML and OpenID and LDAP standards, and they are wrapped by an identity provider such as Okta, Azure AD, and so on. So for humans, they would be able to basically automatically and seamlessly use their existing tokens. Okay, no need for further passwords and so on and so forth. In terms of machine authentication, how would machines authenticate to the secrets management system? This is where there are two types of authentication here. There's cloud-based identity for workloads that are running on top of AWS, GCP, and Azure. And there's the on-prem or legacy-based identity or authentication. So let's first speak about the cloud identities. Within the cloud, we are all enjoying the identity and access management systems of the cloud providers. CIAM of GCP, IAM of AWS, Azure identities within Azure, obviously. This basically means that with secrets management system, you would be able to interconnect an existing workload. For instance, Lambda function that runs on top of AWS would be able to authenticate to the secrets management system seamlessly without providing in any API key whatsoever. You're able to do that, to interconnect with that. With the on-prem legacy world, where you do not have any cloud IAM, right? Within our on-prem, you don't have that cloud IAM, obviously. So allegedly, you would need to use a secret, exactly as I believe that it was, Amit that was asking it. So Amit said, in order to interact with my secrets management system, I would need to have an initial secret. That's right. So you would need to have an API key, assuming that you're not using cloud identity, which is solved in the cloud, right? So within the on-prem, you would need to have some kind of an API key. Some of the secrets management solutions out there today, some of them provide a very good solution for that, which is the Secret Zero solution. It's like a bootstrapping solution that allows you to completely eliminate that initial API key, and those solutions provide you a solution for that. Again, in that particular case, if you would like, I will be able to take that offline with you, Amit, and to provide you what is Akeyless solution for that. It is called Akeyless Universal Identity. You're mostly welcome to read about that in the in our documentation. But basically, you will be able, in having some mechanisms, to avoid the problem of Secret Zero. In some cases, it's a little bit more hard. In some cases, it's much more out of the box, so it will be very easy for you to do so. Now, with secrets management systems, as I've mentioned, the one basically, again, secrets management is the one in charge to make an order in that great chaos of different types of secrets, certificates, credentials, and on that suddenly have become increased in the last few years because of the cloud movement. So with secrets management also comes a new challenge, which is to make sure that that secret management system is highly available and scalable. Now, why am I emphasizing that? The minute that we're saying that your workloads would have to use some kind of a system to fetch secrets on runtime, to fetch credentials, to fetch certificates, encryption keys on runtime, it means that your workloads are actually dependent on that secrets management system. It means that whatever solution that you would choose to act as your secret management system, you would find it highly dependent in terms of availability within your infrastructure. And you would need to make sure that it has all the mechanisms to provide high availability, disaster recovery, and it means that you would need to take care of replication, backup, and monitoring. And this is the new thing around it, right? With the old privileged access management systems, it was a bit okay to keep it, so it's 95% available. You can live with it. If you have 1 hour of downtime, sometimes you can live with it. That was the old PAM legacy things. With the secrets management systems, it's not just about humans, it's now about workloads, and you'll need to take care of the fact that it must be highly available again. And you would need, with multi-region and multi-environments, you would need to replicate those. Sometimes it turns to be a complex IT project. So obviously my suggestion for you is to consider SaaS versus self-deployed solution. And again, would be able obviously to provide you a lot more information about that if you'd like on offline. So to keep some time for more questions, I'd like to just end up with just saying that I just touched the beginning of the solution for the problem for the sprawled secrets, right? You have secrets that are being used by workloads, humans, the problem of data protection. I've mentioned that data protection needs to be managed, and I've mentioned all kind of those data encryption. There are all kind of mechanisms that allow you to basically streamline the whole encryption and signing capabilities within your organization, and to have some tokenization services. It is part of secrets management, and I'll be happy to elaborate, but not today because our time is short. But take in mind, there is also one more thing that we would need to take care of, which is the remote access, right? Remote access by humans is actually a huge use case that requires credentials and short-lived certificates in order to actually happen, right? And I keep mentioning it, that the secret problem is not just about humans, not just about workloads, it's about both too. And the problem is that both of them are using slightly different use cases. So for the human factor, because of the new environments, because of the new way that cloud is running, the perimeterless world, the zero trust movement, and so on, you need to find a solution that would allow you to basically interconnect your internal environment and to do so with a just-in-time access, so that you would not need to go, one, to the VPN, which with multiple environments, it's hard to maintain, one to the VPN, then to go across credentials that would need to be provided for you. So actually you're still saving your own credentials within an Excel sheet, within some password manager, whatever. But again, the employee or the vendor will still need to type those. And then you also need, according to regulation and audit, to record those sessions. And you need to do so for any type of protocols, SSH, RDP, kubectl, SQL, and so on. In order to streamline the process, obviously would recommend you to look for those solutions that would provide you an all-in-one solution to be able to have all of those components work together. The tools that were previously created that basically provide a solution for that particular problem of secure remote access, unfortunately or happily, were actually provided for the old places, for the old types of worlds in which, again, it was combined out of several different tools that required a lot of time and hassle to maintain. Again, VPN, and then PAM solution, and then maybe some connection to certificate management solution. But eventually, I would encourage you, obviously, to look for those solutions that are doing all at once in order to streamline the whole process. Okay, so lots of more other things. Thank you very much for your time. I would encourage you to ask any questions via the email or now, if you would like. So let's answer. Lior, do I have a minute or two to answer?
Yes, we have 1 minute left. So let's see if there are any things. I think most of the people ask for comparisons, comparison with other Vault solution. I don't think we have time. Maybe in the end of the meetup, we will have more time to speak with the finalists.
Okay, so I'll just answer with one quick question. If you're interested directly about Akeyless in comparison to other Vault solutions, I'll just answer with one sentence, and then obviously we'll be happy to answer further, and you'll see more information about our website. But basically, far more functionality, a wider product, easier to use, far easier to maintain, if any, because it's SaaS-based, and obviously stronger security model. We are FIPS validated by the US NIST. And you'll find our TCO much more appealing. You can see all about it in the pricing in our website. There's a very good answers and very good tables of comparisons, and we would be very happy to, and I'll personally would be very happy to provide you more information. With that, Lior, I'll bring it back to you.
Okay, thank you very much, Oded. Very interesting topic. I think it's the hottest topic now. People are talking about it, going to shifting to the cloud. When you're shifting to the cloud, the secrets becomes very interesting, very important things. And as you have secrets from the army, all of us have some secrets that we want to keep. So without further ado, I want to invite Moshe Ferber to talk about cloud architecture, secure cloud architecture. Moshe is a chairman of Cloud Security Alliance. He's actually around here for 20 years or so in information security field, also leading security startup companies. And without further ado, I want to invite Moshe. And Moshe, the stage is all yours.
Thank you very much. So first of all, thank you, Lior, for organizing this very impressive line of speakers. And so thank you for your time and investment. Excellent presentation from Oded. Secret management is definitely one of the hottest topic in this in the industry today. And I've been following Akeyless from afar, and they're doing a great job in protecting digital identities and API keys and all of those sorts of stuff. So good luck, guys, with your further endeavors. And okay, so moving in, let's see if I can move the slides. Okay, it seems to be working. Okay, so I'm here to talk about secure cloud architecture. Just as an introduction, I've been in information security for the last 20 years, but I'm here because in the last 10 years, I've been specializing in cloud services. This is because I was involved with many too many startups. Some of them were successful, some of them were less successful, but one thing was common to all of them. About 10 years ago, we moved to the cloud, and it's really changed the way that we deploy applications on cloud. It's really changed the ways that startups are behaving. We stop stealing computers from all our neighbors and family members, and instead of that, we started building stuff on the cloud, and it's really it's resilient infrastructure. So for the last 10 years, I've been working with the Cloud Security Alliance on producing knowledge, research, and certification. And then I think I was involved in probably all of the major cloud certification for the last couple of years. Specifically for this presentation, is basically built for 4 hours. It's an in-depth look of cloud architecture, but I took the highlights from this presentation. Basically, I took the topics that people keep asking me about, like encryption and log management and monitoring and web application firewalls, and basically put them in some highlights. So let's dive in and see what we're going to talk about. And yeah, we're not going to do this in 4 hours, but I managed to somehow squeeze it to half an hour, where I'm going to talk about the highlights. First of all, I'm pretty sure that all of you understand how a cloud is built for availability. We have the different regions, and inside the regions we have availability zones. I'm using mostly AWS terminology because this is basically my background. But on certain occasion, for me, it's basically the same architecture can be built on Azure and GCP and other cloud providers. I'm just using AWS terms for the convenience, okay? So we all understand that we have different regions and availability zone. This is how we protect our availability. This is how we basically create redundant application. We build them inside the region. We build them into different zones where we put our instances in different zones, and then we use load balancers between them. This is pretty common, so I'm going to jump right in. The question is usually how to architect for availability between different regions, and this is where I want to talk a little bit about CDN. CDN becomes really useful when you architecting for applications that are multi-regions and also multi-cloud, okay? The idea is that your flexibility shifting traffic between region is a bit limited. So CDN can provide you some of those options to move your data between different zones and different regions based on geographical needs, based on redundancy, disaster recovery. Now, CDN, now all cloud providers have them, but currently in the last couple of years, we see more and more third-party providers adding CDN capability, adding security capabilities to the CDN, and this is exactly what I want to talk about. So we have basically WAF and CDN as a service, and we have vendors that are adding services on top of them. This could be DDoS protection, this could be web application firewall, this could be load balancing between regions, this could be DNS management, this could be SSL termination, basically anything that you need in order to manage your, I would say, web services workloads. They're added into the CDN. Bottom line, what I'm trying to say, think about external providers as CDN, and also web application firewall and DDoS protection, because if you're thinking about multi-region and multi-cloud deployments, having some kind of an external access point before the data goes into the different regions, it's very helpful. Of course, I'm talking about providers like Cloudflare, Imperva with Encapsula, Reblaze, Akamai, Kona. All of them are valid providers and add a layer of security on top of your web services. When we talk about web application firewall in general, there are basically a couple of options that you can implement in your cloud environment. You could use third-party as a service, which is exactly what I was mentioned. But you can also take the provider service. All of the providers today have web application firewall. They usually go hand in hand with your load balancer. So when you're implementing, I don't know, even one web server, before you're even thinking about clustering and redundancy, put a load balancer in front of it. Why? First of all, it doesn't cost too much, but the second reason would be because most of the provider services like web application firewall and DDoS protection are basically embedded sometimes into those load balancer. Other option for WAF, web application firewall in the cloud, is going to the store and buying your web application, your favorite web application firewall. Over here, you can choose any web application firewall you want. Your Imperva, your Barracuda, any WAF that you're familiar with, but you need to worry about scalability and redundancy, because when you go to the marketplace and you install your own instance, then you're responsible for the redundancy, the availability, the scaling of this. Some of the, I don't know, this is some of the responsibilities that you can shake off when you are migrating into a service. Another option, by the way, that becomes a little bit more popular in the last couple of years is installing a WAF client on top of the web instances. We have open source options like mod security, and we have a more commercial RASP solutions that are installed on top of the web services. Again, all of those options are valid depending on your architecture. And often I see also customers that are deploying external WAF service, for instance, like Cloudflare or Incapsula as mentioned, but also integrating it with internal WAF service like a marketplace or the provider service in order to enjoy both worlds. So that's it for WAF. Couple of other architectural highlights. Again, I pick and choose stuff that people are asking me about. In this example, you can see how we can build an internal BI application, for instance, business analysis, I don't know, credit scoring in banks, or any BI application that you can build, but you build it in an environment that is totally closed and not open to doesn't have any open ports, doesn't have any public IPs. And how this is done, basically, again, when I'm showing this, I found it amazing that even now, 10, 12 years after the cloud is being deployed, people think that cloud is very accessible, that you always need to have public IPs and everybody can connect and you cannot filter the traffic. But actually, cloud application could be very separated, very segregated from the internet, and not communicate with any external IPs. And by the way, this is the example. So we have the corporate data center on the left. The corporate center data center is preparing, for instance, the files that need to be analyzed, the source of the data for the internal cloud application, for the internal BI application. They upload the data into into some kind of a bucket on object storage. Once the event is occurred, then we have some kind of a function, a Lambda function or a serverless function that catches this event and then takes the file, the data file from the bucket, and basically pushes it into the BI server that you see on the right. The nice thing about this this analysis server, it is totally internal. It doesn't have public IP addresses, no open ports. There are very few attack vectors that could be used against this instance. So the analysis instance is doing the analysis, is creating results. Then he's placing the results in a different S3, in a different object storage bucket. And then again, we have some kind of a Lambda function or some other way to move the data inside the corporate. Again, what have we achieved here? We achieved an application that is working in the cloud, that is taking data and extracting data. It's basically communicating with the internal environment of the organization. But again, no public IPs, no open ports, nothing is exposed from the internet. Very few attack vectors that are available. Okay, one of the terms that you will meet a lot in the cloud is limiting the blast radius. What do we mean by that? When something happens, how can we limit the effect of the incident? For instance, let's say that all my cloud environment is based on one account. then if something happens to my account, I lose access to all my instances. There are various stories where this shit really happened. Bottom line, we achieve a limiting blast radius by creating different environment, different VPCs, by connecting them with specific permission. We call it networking network separation, different networking with different networks with firewall separation between the firewalls and security groups. We also limit the blast radius by using different identities, different roles. We are all familiar with those. In cloud environment, we can also limit the blast radius using different subscriptions, as they called in Azure, or organizations, as they called in AWS. And the idea is that organization is creating different accounts for different business units. And inside this accounts, they create different identities. And what you see here is basically classic Security Alliance methodology of how to create the permissions of those identities. For instance, the root account, root account, the problem with the root account, we mean root not as in Linux, yeah? Root account is basically the primary cloud account. The problem with root account is that you cannot limit the permissions. This is why we are not using it. Best practices are attach the root account to a multi-factor authentication hardware key and store it in a safe. You're not going to use it. Then we're creating the super admin, which is the admin that we're going to use in our everyday life. The super admin can manage everything except from a couple of pillars that we want to keep separated. Which one of those? The identity and access management administration. So if somebody managed to get access to the super admin, he will not be able to add sub-users or sub-accounts. This is some of the insights that we gained from other attacks, where we blocked the user that the attacker was using, but he already mentioned to create additional users for himself. So identity and access management is managed separately. Billing is managed separately. Why is that? Because often in cloud environment, my first indication that something is happening is the billing. Why is that? Because often the first thing that the attackers are doing when they gain access to an IaaS environment, they're launching 20 servers somewhere that is unnoticed, like a region you're not using, and then use it to mine Bitcoin. Exactly, Peter. And the first insight, the first indication of that is the billing. So again, billing is managed separately in order the attacker will not be able to close the billing alerts, to terminate the billing alerts. And of course, we often have in each organization some kind of a security monitoring account that has read-only access to all other accounts in order to, again, access to logs and monitor. Again, this should be separated from those super admins. And of course, everything should be managed in different organizational units. This is all basically cloud provider topology. What I'm saying is, when you migrate to the cloud, think about your subscription/organizational structure. Moving on to data security. So we have basically different storages in the cloud. Volume storage and object storage are the most popular one. Sometimes we also keep data in databases, makes sense. But from the physical, when you talk about this physically, databases are also will be located on volume and object storage. And sometimes we keep data in CDN. Those are basically the major parts, the major places that we save data. We also have sometimes we have XFS or NFS, network file system, but those are basically the major location. Understand the different option when you're planning for data storage. Different storage types has different encryption capabilities. Not all database services can be encrypted. Object storage has its own pros and cons. It's most of the incidents are on top of object storage, so deploy a hard governance. When we talk about encryption, and Oded talked a lot about keeping the keys, I'm going to talk about encryption for a second in general. Encryption is made from three different components. Like everything in the army, it's made from three things, also encryption. So we have the data itself, where it is located. In the example, the data is the blue squares. Basically, we keep the data either in storage, or we have an operating system that is keeping the data, or keeping it in a database. Another component is the encryption engine, where it is located. And the third component is the keys, where Oded was speaking a lot about key management. Bottom line, let's talk about the encryption engine for a second. It is very dependent where your encryption engine is. The higher in the hierarchy the encryption engine is, the better the results are, and I will explain. All cloud provider would probably offer you built-in storage encryption. It's out of the box, it doesn't cost any money, it's very easy to implement. The only problem is that when you implement a storage encryption that is one key that is managed by the provider, which is the scenario for most of the cloud providers, then everybody who's coming from a higher layer, like if you're coming from the application into the database, you will receive an unencrypted information. This is how encryption works. The levels in the hierarchy, the higher level in the hierarchy needs access to unencrypted information. Otherwise, they will not be able to work. So if we encrypt stuff at the storage level, we basically do not protect from anything except hardware theft. And I don't know how well you're familiar with cloud provider, but the mature cloud provider has very good physical security, better than most organizations. So I'm not really worried about hardware theft in those environments. So what I'm saying is basically the storage encryption that most of the cloud provider are offering by default. And also storage encryption is basically adhering to every regulation, because regulation mostly is not talking, regulation are not talking about the location of the encryption engine. They just settle for the fact that the data is encrypted regardless where the engine is. So storage encryption is great for complying to regulation. It is great if you want a cheap solution. It doesn't really protect your data. You want to inspire for higher encryption, to put your encryption engine higher in the hierarchy, like for instance in the OS level where you can encrypt volumes, or at the database level where we usually use something that is called TDE, transparent database encryption. This is where this is something that most commercial databases are supporting currently. Moving on, because Lior is also hinting me that we need to, to move on. Thank you, Lior. Regarding the question from Manish, which MFA technology is best for the cloud, Cisco Duo, I think both of them are pretty much the same. And the question would be what type of cloud service would work better than Cisco Duo? I mean, there are so many cloud services, so you cannot answer for, you cannot have one answer for everyone. One of the biggest challenges today is building CI/CD pipelines. I see a lot of organizations are trying to build CI/CD pipelines that are efficient and secure. There's a lot to be said about this, but let's try to talk in general about how what are the major components for this pipeline. So first of all, the pipeline begins with the code and ends up when you deploy to production. Throughout the process, from the security point of view, we need security gates. Those are basically security gates are basically where we integrate our security testing, because the big question in this pipeline is where you integrate the security testing. And we have a lot of security testing. We checking source code SCA, software composition analysis, in order to check the open source packages. We are doing static analysis to examine the code. We are doing dynamic analysis. This is where we running the application and check for vulnerabilities in the operations. We have vulnerability scanning to scan the infrastructure. We have penetration tests, sometimes manual, sometimes technical, sometimes manual, sometimes automated. But bottom line, throughout the pipeline, we have different tests that needs to be deployed. And you need to make sure that those gates exist throughout the pipeline. And basically, as you can see from the configuration, we are taking the source code This is the code that needs to be deployed, but we're also taking the infrastructure template, like the cloud formation templates, for instance, because we want to deploy the VPC with all the subnets and all the routing. And we're taking the server configuration, because inside of VPC, we need to configure either servers or containers. Yeah, for the purpose of discussion, it's the same. And then we lock it up all in our version control repository, and then we use our continuous integration server. It could be a Azure DevOps, it could be a TFS, Azure DevOps, or it could be a Jenkins, or TFS is the old name. Keep forgetting that. But bottom line, we can use any continuous integration server, but we want to make sure that we operate all the gates. So it's the response. Currently, it's the responsibility of this continuous integration server to make sure that we run all the different tests. I'm not that accurate. Some of the tests are also can be done during the build. For instance, when you download some kind of package from an open source repository, when you download an image, this is also where to do the test. Well, this is also a place to do some of the testing, but some of the testing can only be run by the continuous integration server, because we need a build to test this upon. So this is basically the pipeline that you need to build. Everything under everything you need, the templates, the infrastructure, the source code, all would go to one repository, and then we use it on the different pipelines. By the way, the way that we draw it here is that we first move to test and we move to production. I think best practices today is to have different pipelines for test and production, at least for highly regulated environments where auditors are looking at if developers have access to the production, and might give you some comments on this. My last topic for the next 5 minutes is monitoring. First of all, let's talk about it from the Gartner point of view, give the different names that Gartner gives to the different technologies. This is I'm showing this slide because people are getting confused with all those initials and the short terms and stuff like this. So basically, we have the CWPP, which is the Cloud Workload Protection Platforms. This is basically tools that will scan your workloads. Now, traditional tools will scan your VMs, but newer tools that are cloud ready will scan your containers and serverless. Okay, workloads, basically everything that runs your application. And in the cloud, we have 3 main types of workloads: VM, containers, and serverless. So look for the solutions that will be able to monitor the runtime of your containers and serverless environments. Part of these tools is traditional vulnerability scanning, additional features for images scanning and stuff like this. So this is CWPP, and we also have the CSPM, the Cloud Security Posture Management. This is more about protecting the management dashboard of the cloud. Check for compliance, checking for misconfiguration. For instance, if you have a bucket on your object storage that is open to the public, if you have users that are not open to MFA, if you have API keys that are not being used, CSPM will be monitoring all of those. Now, those 2 technologies sound a bit the same, and they are a bit the same. I mean, the companies that are doing CWPP has started doing CSPM, and companies who did CSPM started to do CWPP. So now Gartner puts them all under one category, which is the Cloud Native Application Protection Platform. And this is the name that they will be using in the next couple of years. Bottom line, companies like Dom9, Wiz, Lightspin, Palo Alto Prism, all of those fall into those categories. Okay, and the last technology that is here is CASB. I think CASB is a little bit over the top now. It's not something new. Most of the large providers now have them built in. It's now a bit of a commodity. The difference between CASB and CSPM is that CASB, Cloud Access Security Broker, is designed for software as a service application. So CASB is to protecting your Office 365, your Salesforce environment. It's basically it's basically designed for software as a service. And CSPM and CWPP are designed for infrastructure and platform as a service. So I know that there are some of the CASB providers that are also doing IaaS and PaaS. They have they have capabilities in AWS and Azure, but the term CASB initially came from from software as a service. So those were the technologies like Gartner named them. Bottom line, when you are building monitoring solution for your cloud environment, those are the things that you're looking for. Okay, you take all the logs. In a minute, we'll talk about the different type of log. You take your posture configuration from the posture management. All the cloud provider have posture management tools built in, or you can take external tools from the marketplace. Example for instance, the guard duty and the security hub from AWS are the posture configuration. Also, security center from Azure is their posture and configuration tool. AWS config is also an example. The idea is that you monitor not only logs, you monitor active configuration. Workload vulnerabilities from the CWPP, basically checking which workloads have vulnerabilities, which workloads have open ports. Examples are tools that I mentioned, also AWS Inspector or the Azure SCCM can give you this information. You integrate threat intelligence either by a third party or some of the cloud provider has services like this, like Guard Duty from AWS, and then all the identity data, the different roles that we have, and this all goes into your security center. This is the center. So basically monitoring the cloud is not only logs as we used to, but also active configuration, and you can integrate also your threat intelligence into that, and this is your monitoring center. And the last slide, just 1 minute, I think, before the deadline. In the cloud, we have different logs. So you need to account for all of them. We have basically the dashboard or portal logs like CloudTrail for AWS or system log for Azure. It covers all the administration data, but it doesn't cover anything. The nice thing about the portal log is most all security information management components, CIAM, security event information, they have good integration to those logs. But there are other logs as well, like the traffic log, VPC flow logs in AWS, and I think they called NSG logs or something like that in Azure. Basically, the traffic logs are also relevant. We have the instance log. We have Linux, we have Windows, so we need to collect those logs. And all cloud provider has different type of logs, like the Kubernetes logs, the load balancer, the CDN, the object storage, all of them produce logs. And over here for the unique logs, you need to have, sometimes you need to have custom solutions in order to collect those logs internally. And this is basically the configuration of those logs, but since we are running out of time, really short, we push basically the logs. All the logs are written to S3 and to the object storage, and we can also push them to CloudWatch, which is the alerts. And then CloudWatch is the way to push them into your existing CIAM, either by engine from S3 or take only the notifications. So this is a look of the architecture, but for all the CIAM vendors, you will see their own architecture in the website, so you can work this out. Okay, let's see if we have questions. I already answered one. So what do we have here? Our company has a test development service in the cloud. We implement all security controls like IDS, IDS container security question for the test, or hosted only a small span of time for, not sure I understand the question. Our company has test and development environment in the cloud. Okay, good for you. Do we implement all security controls like IDS, IPS container security for dev and test, which are hosted only for a small span of time? Well, first of all, I think basically the answer is no. I don't see the need, for instance, for container runtime security inside your dev and test environment. With that said, there are other tools that, for instance, can check for malicious container images, and those are important to implement in those environments, again, because you don't want a messy image or a malicious image to go into your environment. So the question would be what type of container security, of what type of solution. Runtime, less important. but solutions for building the application correctly, like email scanning, are definitely should be also in the pipeline. Okay,
Moshe,
so
I'm sorry, to keep up time, I'm sorry for that, to keep up time and the timeline. So I do want, Moshe, to thank you. We'll answer all the questions in the end of the meetup. If you have further questions to our lecture, so we'll keep up time in the end of the meetup, don't worry. So Moshe, thank you very much. Very interesting lecture. You know, it's the hot topic here, and without further ado, I want to invite also my friend Naor Penso, who is currently the Senior Director and Product Security of FICO. He has vast experience and expertise in cyber technologies, vast knowledge in technology. I personally know him as a CTO of Amdocs, the previous CTO of ITSec in Amdocs, the security department. So without further ado, I want to invite Naor. Naor, the stage is all yours.
Thank you very, very much. Thank you, Lior. Thank you for having me today. So I will just start by saying that this discussion or the next 30 minutes will focus on things that are also security driven. I see that my video is stuck. Apologies for that in advance. But what I wanted to talk with you all about today, or maybe before, and Lior, I don't think that my mouse is working, or it can't.
Yes, give us a sec.
Okay, I need to give it a second. Okay, so just like 10 seconds about myself. 20 years or so in cybersecurity. Today, I'm leading product security and the engineering group that is actually developing cybersecurity microservices into the FICO platform. Most of you might not know FICO, but FICO is the company that does the credit scoring for a lot of, so all of Americans, a lot of the European countries, and also does a lot of things in the data management and data decision management world. So essentially a data analytics company. On side notes, previously the CISO for Botech, as Lior said, the cybersecurity CTO for MDocs. Today, generally investing in early stage startups, mentoring and advising startups, aside from my day job in FICO. And the topic I chose to talk to you about today is observability and observability from the security side of things. So I don't know if you heard about that buzzword, observability, but we all, as security experts being in the market, we have all, learned and grew up on the fact that logs are a significant part of our ability to detect and respond to cybersecurity attacks as they occur. Of course, with the evolution, with big data analytics and such, we've got more predictability, the ability to create anomaly detection and more behavioral analytics. But at the end of the day, logs have been a fundamental part of cybersecurity or information security for many, many, many different years. Observability is not a new thing. It has been here for quite some time, but essentially it is an encapsulation of logs, which is one of the things that are encompassing observability, but also traces and logs, and metrics. So today, when you're thinking about observability, you want to understand how an application is functioning. How the application is functioning is not just did the user log in, I ran some report, those are the log side of things. It is also the duration they took, what is the performance of the server or the services or the containers that are running the service itself. And essentially, observability is the encapsulation of everything, being able to provide organizations like FICO, where I'm working today, the ability to actually learn, understand how the environment is functioning, how it is operating, if there is a need to deploy more services or auto scale. And of course, as a sideline thing, but a very important thing for our discussion today, is the environment secure? Are we seeing any behaviors that we haven't anticipated? Are we seeing any type of attacks on our environments? So essentially, the bottom line is if you're thinking about observability, in order to reach observability, you need to monitor different application outputs. That includes metrics, traces, and logs. And with this, I will jump back to observability in just a couple of slides. But I wanted to talk about one of the big changes that are happening today in the software world in general. And I do assume that every person on this call that has been or is working for a company that develops some software have heard the name or have heard about microservices. And the reason it is important to talk about microservices and talk about how applications were built 10 years ago, 5 years ago, even today in some cases, and how microservices and modern applications are being built, is that if you're thinking historically, you wanted to log an application. Let's say that I have an application that processes invoices. If I wanted to log what is happening in the system and understand if the application is under attack, if a customer is under attack, I had everything under the same roof. I had the same development manager, the same development lead. I had the same engineering team. I had the same operations team. So it was very easy to come and say, guys, these are the things that we want you to write in the logs. These are the things that we're expecting to get. And you had a single owner and one application stack that actually wrote everything, right? So from start to end, from the point that an invoice got into the system up to the point that the application finished processing the invoice, it was one event. It was one event from one system. Nonetheless, today, when we're thinking about modern applications, it is significantly different. The idea in modern applications is that instead of creating a very, very big component that will do everything under one roof, you start developing much, much smaller components. Every component has a different responsibility and a different piece that when you're binding it all together, it provides you that oversight and that holistic transactional view that you need. But if we're taking it to, as an example, logging, that means that if in the past it was one event log saying a file was uploaded to the system and we scanned it and this is the result for the invoice handling, today you have many different microservices. And so a business transaction can be built from, again, anywhere between 1 and 10,000 and even more services. I can tell you that in FICO, we have hundreds of services. So a single transaction can touch many different services. And literally, when you're thinking about a service, it is an application at the end of the day. And because of the way that it is being built, you cannot really build a meaningful event out of just one service. So it's not like one service owner can build the entire subset of things we need in order to understand what is happening in our system. Another point of congestion, or another thing that makes things even harder, although of course it is much better from both a design and architecture and a software point of view, is statelessness. So if you're thinking about services in the past, it was a service per customer, a service per owner, just like you would have installed it on premise. Today, when you're thinking about SaaS companies, as an example, they don't really care who is the customer, right? When you're going and logging into Gmail, it is not that Gmail has a specific instance for your mail address. It is a single system with many different users. And if I'm taking it to a more enterprise world, if you are using Salesforce as an example, you are not really using an instance that is completely dedicated of Salesforce for your usage. It is shared. That means that the front end is being shared between multiple customers. It means that there are other processing services that are shared between multiple customers. And that means that a service might not even know who is serving. So think about converting currency. If I needed to convert currency from Israeli shekel to US dollars, does it really matter who is the customer I'm serving? Probably not. All I need to know is what is the sum of money I want to convert, and let's say which date it is, because currency changes, of course, but that is pretty much it. So how can I really still know that currency activity is bound to a single customer? And how can I actually know that an entire life cycle is associated with one transaction? And that is a very big challenge in today's modern applications. When you are starting to scale, it is becoming increasingly hard to really understand what is happening in your system. And this is where essentially observability comes into play. This is where the observability world comes into play. So first of all, a little bit about the high level glossary for observability. So a metric is essentially a data point. It can be a simple 1 digit or 2 digits or an integer that represents how much time it took to run an action. It doesn't have anything. It might have just the identification of what action it is and just the duration, as small as possible, in order to deliver that in hyperscale, which again, think about billions of transactions per minute or per day. You need to be able to rationalize the data in a fast way. The second term is a span. So a span is a single operation that is being logged. A span can be one specific metric, okay, from one specific system. A trace is a group of spans. So when you're thinking about how will I actually know, and let me annotate on the screen. Okay, I don't know if you can see my mouse now, but essentially, when you're flowing through the processing, how can you actually bind a span from the file transfer to a span from the OCR microservice to a span from the ETL? All of those will be bound under what we call a trace. And then we have a log or a log record, which is the traditional security notion that we understand, which is the timestamp, what happened, who, what, when, where, how, etc. All of this, by the way, it is important to mention, the glossary is based out of OpenTelemetry. OpenTelemetry is the de facto standard in the market for observability. It is open source, but it is supported by companies like Google and others. So it is very well founded. So when you're thinking about spans versus traces, as I mentioned, there are spans being created for each and every one of the microservices, and then you have a trace for all of them. Now, at this point, I will actually start jumping into the security part of things, because up until right now, nothing is about security. And the point about security is that we have a very big problem. In security, it was easy for us in the past. We collected log from an application. We collected an event, an event, right? It said, at this point in time, user Naor generated a report, and this is the report, and it succeeded, and everything is great. Today, in order to construct that simple event, it can mean I need to aggregate data from 50 different services. And that is essentially substantially different from what we were used to do in the past. So again, examples to that, the currency conversion service may convert currency, but it doesn't really know who it is converting to. A business transaction can be 15 different services. Some services might fail. So in our rationale as security people, we always have success and fail, right? But if you have 20 services in a line, right, and only one of them have failed, does it mean that everything failed, or does it mean that it was a successful thing? So those are the sort of questions that we need to start asking ourselves as security people, because usually we care about the failures just even more than we care about the successes, right? In the time of the event, again, it is broken down. So I have a timestamp from many different services. It's not just one timestamp. So how do I actually know when something happened, when it is a rolling activity? So who is not known across the board? What can be a lot of different things? When and where are single points, and success and failure is ambiguous. That is the biggest challenge that we have found when we started working on observability in FICO from a security standpoint. When you're starting to build microservices and scale microservices, it is becoming immensely hard to actually identify what is happening in your systems and being able to do the right security tracking and auditing. And this is where Cornerstone comes into play. I will say, before jumping into Cornerstone, which is, by the way, a project that will be very soon open sourced, and everyone are encouraged to go in, read the spec, contribute back, that would be great. It will be, again, completely open source. It's not something that we have done to keep internally. But I want to provide some context. So what we're trying to do, what we need to do as security people, what we need to do today in a modern application is that we need to start collecting data from many small services, being able to bind them together and then reconstruct them into a meaningful event. So I think that the keyword, and I will repeat that in a lot of times in the upcoming couple of minutes, meaningfulness of the event. An event that is not meaningful is useless for security. If you have the, I don't know, let's say a user failed to authenticate 10 times and then he succeeded, but you don't know the username, that event is meaningless, right? You can't do anything with the data. And for us in security, the meaning is the most important piece. That is why we always talk about the who, what, when, where. That is pretty much what's building the meaningfulness of events. So essentially, when we're thinking about modern applications, the meaningfulness can only come into play when you are aggregating a lot of small data points into a larger scope that actually defines how the application is behaving, how the greater transaction or how the transaction the customer is expecting to have is actually happening. So what is Cornerstone? Cornerstone at the end of the day is a unified and expandable specification of events that enables product teams, developers to create a consistent and unified view structure for events across the board. So when you have one application, and I some of you that might have done SIEM projects, SIEM projects, when you need to integrate a new data source, you are starting to reverse engineer the structure, you are building a data point, right? And then you can start ingesting it, building rules, etc. The problem with microservices is that if you have 100 of them and everyone is building their own structure, then you need to reverse engineer 100 times the structure of the event. And it is not guaranteed that all of the events will have everything you need. So essentially, Cornerstone started from, we want to be the de facto standard to how events are being built in an application. It doesn't matter if it's a monolith, if it is a microservice, it is just a way to enable everyone to talk in the same language. The big difference between that and what some of you might know as Splunk Common Information Model, Elastic has their own, the people that have been in the industry for longer, ArcSight CEF, Common Event Format, is something that is well known. The difference between Cornerstone and those is that Cornerstone does not just define what are the fields. It also defines the relationship between them, what is needed, so what is mandatory, what is optional, what is conditionally needed from the product teams, and when teams are starting to adopt it. Actually, what we are doing is that we are abstracting all of that SIEM integration into Cornerstone. So think about product teams building events in a way that you don't need to think about. You can just onboard it automatically without even thinking, how am I breaking down my event into a SIEM ecosystem? So essentially, that is Cornerstone in general, and a little bit into how it is built. So first, the ground rules. Cornerstone does not define what events the team should log, right? The what is still driven by the business logic. If the company is a retail company, the what will be different than a data science company, than a financial company, than I don't know, a security company that builds missiles or such. The what is different based on the business use case. So that is the first thing. Cornerstone doesn't define what. It defines the how events will be logged, which is, it does not define how the events will be logged. Event will be logged, will be continuously logged as they were in the past. So if you're using, as an example, Fluent D or a Splunk heavy forwarder or any sort of log aggregator, essentially you can still use the same shipping mechanism. It is not changing that fundamental. What it does define is the structure of the event, or how the event is built, from the basic fields, who, what, when, where, to the more extended ecosystem, who initiated it, what was the impact. The second fundamental is that Cornerstone is contextual. So the most important piece and one of the things that are missed the most is that context. So think about a framework that provides you that core event structure, exactly what needs to be in that, and then you have contextual logic. If you have data associated with the event, then you can add the data context and break it down into smaller contexts, such as information context, database context, and I will touch that in a second. The user context. So if there is a user involved with the event, you can add the user context into that event. All of those are conditionally added into the core event. So you can always have the very, very smallest amount of data you need in order to make the event meaningful. However, you can always extend that based on the business needs and based on the security needs. And the third important piece, regarding the structure, and this is just a high-level view of the architecture itself. I will not actually touch that right now because we will need a few hours to actually review the architecture. I will say that Cornerstone is built to be an addition or a plugin that is working with different tools like FluentD, like FluentBeat, like Splunk Heavy Forwarder. It is not necessarily replacing it, which is an important piece. However, it does provide some conditional logic for consumers, because one of the things is the security team wants to get some of the logs. The operational team wants to get some of the metrics. One of your customers wants to get only the subset of data associated with that specific customer. All of those can actually run and coexist inside the Cornerstone collector. However, I see that, never mind, apologies. The example of how the Cornerstone event structure is built. So this is actually an event, this is a core event. So this is the very, very basic. You will see on the side mandatory, optional, and conditional. I will talk about that in a second. But essentially what it provides a single way of describing the event. And think about all of the product teams. And again, the more companies move into microservices, the more companies move into larger development organizations, that consistency and persistency will become immensely harder. But you have a single pane of glass and you have a single way of writing those events, meaning everyone can read each other's events in a very easy and consistent way. So this is actually an example of a change password that has failed. It failed due to the fact that the password does not adhere to the password policy. But you can see here the event ID, you can see the environment ID, and you can see some of them are actually optional. So event signature is not mandatory. The deployment environment is not mandatory. However, environment ID is conditional, and I will talk about what is conditional in a second. And then you will see the things that are important for security, as an example, as mandatory, the type, the subtype. This is an example of the user context. Let's assume that we had an initiating user. So who was the user that initiated the event? If we have a data import, what was the data import? What did it include, etc. Of course, it goes into virus scanning, etc. All of those sort of things. And then the usage logic, which is what I wanted to touch on earlier. The usage logic is very interesting. So instead of coming and saying everything is mandatory, everything is optional, you choose whatever you'd like, essentially there is a rule-based system and a rule and a logic system within Cornerstone that enables teams to understand what do they need to do. An example to that can be if multi-tenant is true, if it is a multi-tenant service, then you must provide the customer UUID, and it is still optional to provide the environment UUID. So essentially you have different field types and different field requirements, and that is what drives Cornerstone to be a very easy to implement mechanism. I want to keep some time for questions, so I will jump real quick. If all of the microservices are talking in the same language, and I will say it up front, Cornerstone is not just built for microservices. Every architect in this room that wants to talk to his product team and tell them, here's how we want to receive the logging, it will work the exact same way. It just has a lot more values in microservices. When you have a unified framework, you can have unified logic, you can have better root cause analysis, better detection uniformity, and better product support. And an example to that is this outlook that will be shared again as a part of that open source project. When everything is built in the same way, when you have the same event structure built across the board, what you can do is that you can, in your SIEM system, describe events once and describe the fields that are required for those events, and then already associate all of the rules and all of the widgets and all of the dashboards into that. So think about the product team coming to security. What do we need to log? No issues at all. We expect you log the user authentication event and here are all of the input fields that are required. We are expecting to see all of the privileged authentication events, and this is what we're expecting to see. So when you're thinking about Cornerstone, think about building your security rules in your SIEM system once and let it be applicable to all of the applications that are being developed by the product teams. That is the outlook for the future of Cornerstone. One last point about Cornerstone regarding metrics and observability. The idea with Cornerstone is that by adding each and every one of the code snippets within the collector, we are actually aggregating and creating one meaningful event, even though it ran through 10 or 20 different microservices, which is what security expects to get. Security expects to get what is the business activity that took place, exactly what needs to be done, and that is what Cornerstone delivers. Again, first, happy to talk about Cornerstone further. We are definitely looking for peer reviews, and in general, it will be open sourced and everyone will be able to use it. Thank you very much. And if there are any questions, I'd be happy to answer.
Okay, guys, if you have any questions to know, please write them down in the chat. So we have one question from Kobe Levy. I know, how do you know the origin of a specific action in a multiple microservice architecture?
Yeah, that's a great question, Kobe. So the idea when you're using traces and spans, essentially so when you're using traces and spans, you essentially also have a transaction ID that is bound to every event. The idea and the way that we have implemented it is that every microservice, unless he sees in the payload, in the request, unless he sees that transaction ID, he is generating a transaction ID. So the trace and spans, first of all, are one of the things that aggregate everything. And then there is another part, which is the transaction ID. And that transaction ID is actually created by the first initiator of the chain of activities. And every service is validating whether that transaction ID exists or not, or the trace ID, depending on the implementation. If they exist, it does not recreate them, it just adds another span. If they don't exist, then it creates that new one.
Okay. Okay, I hope that's answered the questions. We have another question. How do you know to connect an event in an async process?
Yes. Yeah, again, a great question. When you're using PubSub or any other technologies that might be, that are not synchronous, the way that we have implemented it is that inside the payload, we save the transaction ID or the trace ID so that it is still moving forward down the path. And when the Cornerstone collector picks up on that, it is essentially aggregating the data based on that field ID. So even if you're writing to a Kafka topic, as an example, one of the fields you will be writing is the trace ID, so that when something picks up on that message, it continues dumping spans into that transaction ID. It does create an interesting use case where you might have, two span IDs that are coming at the same time because two services collected from the same Kafka topic. But at the end of the day, this is how it's being implemented. I hope that it makes sense.
Okay, thank you very much, Naor. Very interesting. And as Naor said, he will publish all the code in Git or somewhere, so you can of course consume his project and add and contribute to his project. So very good initiative. Thank you very much, Naor. Very insightful lecture. Thank you very much.
Happy
so,
thank you.
Yes, Naor. Yes. What do you want to say? Sorry.
No, just happy to be here, and I will hand it over to Ori, which actually I saw a couple of questions that you will definitely be able to answer. So that will be interesting.
Yes, yes. So of course we will answer all the questions. We will also leave time in the end of the meetup. So if we are running out of time for each lecture, we will keep time in the end, so we will be able to ask any question you need to for all our panelists. So without further ado, I do want to invite Ori, who is the VP R&D of Akeyless, who can also, of course, answer all the technical. He has a vast technical experience and is actually the hands-on behind the Akeyless. I think we can say it like that. Ori will also present a demo on how to manage secrets in Kubernetes. So guys, bear with us, very interesting lecture. So Ori, the stage is all yours.
Thank you, Lior, Naor, and everyone. First of all, just a minor correction. I'm part of a huge team that is doing amazing work in developing the product that we have, the platform. And I'm going to talk about a specific topic. It's probably interesting for a lot of companies, which relates to one of the most familiar and popularly used Kubernetes as the container orchestration, and specifically about security concerns related to it. You can switch to, so I'm having control, let me see.
Yes, yes.
Okay, perfect. So you guys have heard a little bit about Akeyless, so I will not repeat too much, just basically talking about a platform that serves all types of use cases, from secret management to key management and zero trust remote access, based on unique technology that allows the customer, the user, to have zero knowledge encryption, which means that even us as the cloud provider or the SaaS provider does not have access to the actual secrets. We are unable to decrypt them. Only the end user can. Okay. Can I switch to the next one? Let me see. Okay. So just in a few words, I know that we covered that, but just to make sure that we're all on the same page, a few words about secrets and why they're so important. Secrets are small pieces of information, digital information, that are typically used for authentication. This refers to either humans, then, for example, when you use a username and password to a specific resource, like a database or anything like that, or a web application. It can be API tokens, API keys, encryption keys, and so on. Most of the modern applications today needs to interact with another resource, right? And to do that, they would need to authenticate themselves, and therefore they would need access to secrets. The main concern about secrets is how do you protect them, in the sense that if the application, which is not a human and cannot prove or easily prove its identity, then you need to feed it with some kind of secret, which for historical reasons were part of the configuration files or even inside the code. The main concern about it is someone unauthorized will have visibility and access to those credentials, and therefore will be able to authenticate itself to the resource without anyone knowing this violation, this security violation. So protection is definitely one of the things that we want to do with secrets. But the second part, because we are talking about large number of secrets and different types of secrets and different types of users for those secrets, we also want to add another layer of management, because it's not enough to throw them in one place. You need to be able to have a clear visibility and traceability of each and every request. You want also to be able to revoke access in case there is a security violation, or in case you monitor something or one of the alerts came up. And for compliance and governance reasons, you also want to have a clear and easy to read and track audit logs for specific operations. And also, as Naor mentioned, also to be able to correlate them with the actual user, the requesting user. When I say user, they normally refer to either humans or applications, machines, and so on. So what are Kubernetes secrets, and how do they correlate to that topic? So Kubernetes is probably the most popular container orchestration tool today. It's becoming the de facto standard when it comes to modern infrastructure. It was initially published back in 2014. The official release, I think, was somewhere mid 2015 by the Google Cloud Platform as part of their GKE infrastructure. And today, all of the major cloud providers, definitely the top 5, are offering managed Kubernetes services. Other companies and other organizations are using self-hosted Kubernetes service, and as I mentioned before, it's running different kinds of application. It will need to authenticate those applications to different kinds of resources, and you need to come up with a solution on what to do and how to facilitate those applications with secrets in a secure fashion. Many applications, that, as I mentioned already, are still using secrets, unfortunately, as plain text, which it makes it easier for a potential attacker or hacker to get access to them. There is a solution, an existing solution as part of the Kubernetes infrastructure to store secrets and facilitate them to application code. However, surprisingly enough, it's not much better than storing them as plain text, because in practice, they are not being encrypted, rather than base64 encoded, which is a computational operation that can be easily decoded without the need to use any kind of encryption key. So I think what we try to aim at the first stages, when we're talking about production environments, how can we make secrets secure? And what is secure? Secure is starting by encrypting those secrets, definitely at rest, and preferably decrypted only at the application level, meaning that at any point in time they are being encrypted, and only the application that actually uses those credentials would perform the decrypt operation and use it in order to authenticate. The main concern about encryption is, in order to decrypt or encrypt any kind of value or any kind of data, specifically secrets, you would need access to an encryption key. And then the next question that comes to mind is, where do I put this encryption key, right? Because the application would need to have access, and you kind of have a chicken and an egg problem, because the key by itself is something that you also need to protect and also need to secure. And a potential hacker would say, okay, so I have access to the key, now I will use the key in order to decrypt this secret. So this is known to be the secret zero problem, and there are various solutions to that. One solution is basically using a protected machine identity when it comes to machine-to-machine communication. And I'll elaborate about what is considered to be a secure machine identity. And the second example is when talking about humans to use multi-factor authentication, which is another layer that without the ability to prove access to specific resource, you will not be able to use encryption keys or secrets or of any kind. About trusted machine identities, in the cloud world, all of the cloud providers are offering machine identities as part of the infrastructure. So whenever you launch an EC2 instance, for example, in AWS, or a virtual machine in Azure or in GCP or anywhere else, basically have the ability to identify itself, get a signed token by the infrastructure that can be validated by external entities. Another example is when you're running on Kubernetes, you also have service accounts that can receive JOT tokens signed by the control plane, and then you can validate the identity of the running application or running pod. Akeyless also offer another type of authentication method. We call it Akeyless Universal Identity, which was invented just to solve this secret zero problem. It's basically associating an identity to a specific resource or an application in a way that cannot be used elsewhere without the platform identifying it or knowing about it. That's all fine and good. Another question that comes to mind is, what if my cluster, and this is very typical in many environments and many applications, my cluster is running different kinds of applications. Okay, it's running a database, it's running some web application, it's running some another application, and each one of those require a different set of secrets. To meet the least privilege principle, you want to grant access to specific set of secrets per application or per namespace, and that's something that is not trivial to do or not out of the box. And this is another thing that I'm going to show later on. How do we do that? So let's move to that second problem, and this is the problem of segregating access to secrets per specific pods or namespaces. And again, we want to make sure that the application will get access to a specific set of secrets. This means basically that it needs to pass the authentication phase at the beginning, and then to be authorized to specific set of secrets that it needs to have in order to perform normally. So the authentication phase is done using one of the trusted machine identities, as we discussed, but your authorization has to have another type of mechanism to the secret management platform, as we will see in a bit. The second question, or the third question that you need to ask yourself, it's fine that I have a cluster, I have different applications on that cluster, I know how to authenticate applications, and I know how to authorize them to have access to specific secrets, but who, meaning humans, which individuals will have access to my cluster, and how can I control that access? And this is what we call the problem number 3 in this case, the cluster access and management. And today, when you provision a cluster, it's normally associated with a client certificate, which defaultly is set to a long-lived certificate. Long-lived meaning that it expires after a long period of time. Normally, we're talking about months and maybe even a year. And this will allow any individual with access to this certificate to be authenticated to the control plane, to the API server, in order to perform any kind of operations there based on the permissions and roles associated with this PKI certificate. In Akeyless, we know how to act as a trusted CA. Other solutions can do that as well. But the idea behind that is that you have a private key that the server trusts. And with this private key, you sign a short-lived PKI certificate, which will be used to authenticate to the cluster. The advantage about having short-lived certificate that after a short period of time, as the name implies, they will expire, and therefore you will need to regenerate a new certificate in order to continue and authenticate to the server and continue to work against it. Same goes another implementation, but so another type of implementation, but same in concept, is using short-lived temporary service account tokens. And then the same manner, you need to reissue those service account tokens in order to authenticate to the cluster. Why is it such a big advantage? Because whenever you want to revoke access, it's as simple as not allowing this user, this client, whether it's human or machine, to regenerate new certificates or regenerate new temporary access token. And because they're short-lived, they will expire after a short period of time, and you will not have access to the server. Another advantage is because you need to communicate with the secret management platform that either issues those short-lived tokens or PKI certificates, those operations are being audited. So as a bonus or as an advantage, you can also see the traceability and the ability to govern and manage all the access to the server in a single unified place. And this audit logs, by the way, can be forwarded to your existing SIEM systems. So if you're running, I don't know, using ELK or Splunk or any other solution, you will be able to control and monitor them and basically even build dashboards and alerts based on this information and control it in a much easy way. And I also talked about the access revocation, and this is typically to be able to prove that you're able to respond quickly in case of security incidents and revoke access to the Kubernetes cluster. Let's talk about the solution for all of the things that I mentioned before, all of the 3 problems that were discussed. So the first thing, instead of using the built-in Kubernetes secret store, which has its limitations, we want to use a secret management platform that protects, meaning encrypting secrets, and they are being decrypted at application level. Also, to have controlled access to the cluster. In addition, instead of using a token or an initial secret or a key in order to authenticate to that secret management platform, use a trusted machine identity in a way that it cannot be used elsewhere without us knowing that or be stolen and used by another entity. Such cases for trusted machine identities is the cloud IAM, the Akeyless universal identity service accounts, and so on. there are two types of, two categories of secret management platform known today. One of them is self-deployed or self-hosted solutions that you need to have your own infrastructure to maintain them. There are advantages and disadvantages to each one, but the main or probably the obvious penalty to that you need to have a larger operation and also pay for those hosted resources to make them work properly. Specifically, if you want to maintain them highly available and scalable, so you have lots of resources running. And the second type of solution is SaaS platforms such as Akeyless, but also provided by the cloud providers themselves. Again, each one with pros and cons, but I think that at least in terms of ease of use and ease of consume, SaaS platforms are much easier to use and deploy. Now I want to show you a quick demo. I'll share my screen. Oh, I need access, Lior, to share my screen. Okay, I have it now. Thanks. And I want to take you very quickly to my terminal. Just to show you, I have like a small Kubernetes cluster here that have some pods here running. And in order to use secrets using the Kubernetes secret mechanism, you need to create a secret initially in the secret store, and then to consume it using a specific annotation. It can either be using environment variables or mounted file system. I've created a dummy deployment, and this is the file here. And this dummy deployment is basically running a pod with a single container based on Alpine very minimal Linux version. And as you can see here, we have annotation. This annotation is going to be read by a mutating webhook that you see it here, a sidecar container that is provided by Akeyless, by the secret management solution. And this annotation can be done in one of two ways, either to inject a file. I'm showing the two ways in a single deployment, even though you can also use just one. So in this case, you have injected file system, a secret called secret1 and residing in this specific folder. So this is one way of doing that. And the second one is defining an environment variable. And instead of the value, which should be the actual value of the environment variable, we put an annotation starting with Akeyless column and then the full path to the secret. Okay. So if I switch very quickly to my account here, you will be able to see that I have those two secrets there inside the Kubernetes cluster. And here they are, secret 1 and secret 2. Once I deploy it, and I'm using, by the way, AWS IAM in order to authenticate my cluster, right? Because I'm running on EC2 instance. Once I deploy it, for example, then you will be able to see that I have this test pod running, right? And I will use the logs to show the std out of that specific pod. And then you can see that the first secret value, this is actually the string coming from the secret management platform, and this is the second value. As you can see, if I try to decrypt it using the web UI interface, right? So you see the secret value here. In addition, I can also very quickly switch to the audit logs and see that there were two get secret value requests. Both we were using Kubernetes AWS.
Ori, I'm sorry to interrupt. Ori,
Yeah,
I'm
sure.
sorry to interrupt. People are saying that we are still seeing the login page. Are you switched to another screen?
Yes, I have switched, and
Okay, so we can see just the login presentation with your email and passwords.
So let me try to pause very quickly and reshare.
Okay.
Thank you for letting me know. Let's see if it revives itself. Do you see anything now? We're still in the login screen.
Yeah, still in the login screen.
Okay, let me try to stop sharing and resharing, and hopefully this will solve itself. Meanwhile, I'll explain that verbally until this screen restores. Hopefully this will be done in the next few seconds. In the audit logs, you basically see the requests done by the application pod, and you see also the secret name that was requested and the entity that requested it, including the IP address. A little bit about the mechanisms behind it to allow this work to be done. So there is a sidecar container, right? A mutating webhook that receives events whenever pods, application pods are being launched. Whenever we see this application pod being launched, we look for specific annotations, and based on that, assuming that we have access to those secrets and assuming the annotations are enabled, we inject an init container to this application pod that receives an initial token, a one-time temporary token with access to those specific secrets. This init container is also the one responsible to perform the environment variable injection, as well as the mounted file system. So the actual pod, the actual annotation pod running within the same, the container that running within the same application pod will be able to consume them in a seamless manner. When I'm saying seamless, I'm referring to the fact that the application pod is not aware that there is another secret management platform serving it. Okay, it does not require any SDK integration or any kind of modification to configuration file. For this pod, it's simply receiving the secrets. Okay, I see that you took over. Yeah.
Yes, yes. There is some problem with the sharing.
Okay.
Do you want to
Is it
try
on your
again?
side or on my side? Yeah, I want to try again, but right now it looks like I cannot share.
Okay, if you want to, now you can.
Let me see. Yes, let me see now. Is it any better? Still unable to see?
No, no, we cannot see.
Do you see a black screen or something? What do you see?
Nothing.
Nothing. I see. Okay, so I'll use the time to answer questions if there are any. Let's see if this is sorted out. I see a question from Ido, right? How do you protect private master key inside the key management platform? The master key, CA, private key, this is an excellent question. And this is one of the reasons why it's not so simple to implement by other platforms. There is a chicken, it's not like a chicken and egg problem, like there is a bootstrap problem to protect the initial key. And because of our unique technology, because of the DFC technology, our keys, our encryption keys are never residing as a whole at any point in time, not even in memory. So when we create a key, we basically create fragments in different geographic locations, different environments. And this patented technology allows us to perform cryptographic operations without combining them. So the traditional case is that you have a key in a single place. You need to store it in an HSM, or you need to store it in a protected device that will not allow others to access them. But if they're not existing at any point in time, then there is pretty much nothing to protect. It requires some, I know it's not, it sounds like hand waving, but it requires some understanding about how the technology works. But this is actually replacing the traditional HSM, and we can act as a virtual HSM ourselves. And with that, the key is in the most protected way, because there is no single place that you can hack into and grab a hold of that key. Hopefully this answers. Let me see if
I can see another question, Ori, and it was in the beginning of the meetup. It would be great if you show differentiation in approach in regards to key clock and other solution.
So I'm not sure I understand the question. Key clock as an IDP. What is the specific questions about key clock?
So I think key clock as a key repository secret management.
As far as I know, Keycloak is a vendor, an open source solution for identity provider. It allows both XAML and OpenID authentication methods. The Akeyless platform is able to interact or integrate with any IDP, any external IDP, whether it's Okta, Keycloak, Auth0, anything like that, ping identity, and basically authenticate clients without the need for us as a platform to manage the users in two different places, right? So you continue to use your own IDP. We use this identity based on protocols like SAML and OpenID to connect you to the platform, because we have a trusted entity, trusted application that knows how to validate the authenticity of the user. I hope this covers it, but if I missed the question, please let me know.
I think it does. Guys, if you have any questions to Ori, please feel free to write them down in the chat. If you have any questions to maybe others lecturers, please write them down. Feel free.
Okay, so another question, what's better to use HashiCorp Vault, which is the de facto common external secret management solution, or native from the cloud providers to work with secrets, or maybe advice, case study? Okay, so the question is basically, let's call it a centralized secret management solution. Could be HashiCorp Vault, which is one of our competitors, of course, versus using the cloud native. The one that I'm thinking about is the cloud native are typically closed garden, in the sense that they work very well inside their own infrastructure. But if you want to work on multi-cloud or hybrid environment, this is much harder to do. It's possible, but it's much harder to do. And if you want to have a unified environment in access to secrets all in one place, then the recommended approach is to use some centralized and unified secret management store. Another difference is the how complex it is to set up a production grade environment versus to use SaaS services like the cloud providers. With HashiCorp Vault, I mean, you do need to have your own resources running them. You do need to make it highly available. And with the enterprise offering that allows you to have multi-tenancy and multiple clusters that will allow you cross-region replications and so on, this is also becoming very costly. So you need to also to make sure that all of your production needs are being addressed. So it's not just enough to spin up a single instance running this secret management, because if it fails, your entire workload is unable to perform its operation, because there is no access to secrets, and not humans and not machines can connect to it. So you need to make sure it's highly available. You need to make sure it's scalable. It knows how to scale as a result of your workload and demands. And you need to make sure, in case you're a global organization, that it's also supporting cross-region access.
Okay, thank you for that, Ori. Guys, if you have any further questions to each and every one of our lecturers, to Naor or Moshe, please write them down in the chat. We will answer all questions. Don't worry, we are still here. I'm now reviewing the chat to see if we answer all the questions. But if you have any, please write them down. So there is a question or don't from none to none. So is it right that in most cases inside one cloud provider, native service covers all need about secret management? Interesting to know your point of view, because you saw a lot. Maybe Moshe, it's for you. I think you can take it.
Well, I already answered it through the chat window. Basically, I said that the local services, the cloud environment services, are good for beginners. They have their own problems. There are like 5 cloud providers with different secret stores. But in one general note is that, first of all, the secret store is managed by the cloud provider. So if you want to protect yourself from the cloud provider, this is one con of the secret store for the local cloud provider. Second, they are mostly adapted for their own services. And if you're trying to keep secrets that are coming from other services, they might fall short. But if anyone can also shed a light on this, is Akeyless guys, because I guess they've seen so many secret stores. Yeah, so
I can tell you that. Sorry.
Would love to.
I can tell you that in many cases, in many corporates, large organizations that we work and talk with, we are hearing a lot of concerns about privacy. I mean, as respected as the cloud providers are, there are compliance and regulations that does not allow certain organization to have access to their most secure assets like keys and secrets by any third party. It doesn't matter which one. So the privacy aspect is super critical, and therefore they are being forced to implement their own in-house or self-hosted implementation of secret management platform. And this comes with a penalty, as I mentioned, of the operational overhead that comes with it. With the Akeyless solution, you don't need to choose which part of you're giving up on. You don't need to invest a lot of energy and time in maintaining this infrastructure and self-hosted environments on one side. And on the other side, you don't need to jeopardize your privacy because of our unique technology and because of the DFC solution that allows you full privacy in terms of accessing to your secrets and assets. You get a win-win situation. Anything else, Oded, that you wanted to mention?
Yeah, I would just add several differences. The cloud service providers, to be more specific, there are all kind of functionalities that they're just not providing. One of the famous, I think, maybe features within the secrets management realm is the notion of providing just-in-time secrets and dynamic secrets. You would find all kind of maybe closed features to that. But whenever you would like to create just-in-time features, just-in-time secrets, credentials with the cloud service providers, you would not be able to do so with any third-party databases or the application-level databases, regardless if they're SQL-based or not. There are many platforms that, if you wish to integrate them with the cloud service provider's secret manager, you would not be able to do so because no one have ever written any plugin to that. So if you're let's say one-stop shop within your cloud provider, mostly one region, one environment, and mostly a simple one, then yes, you can continue. You use most probably your AWS secret manager, for instance. As soon as you go to multi-region / or if you use any third-party platforms, you're using Terraform, using Jenkins, using your own Kubernetes on top of your IaaS, then surely you would need to have a third-party secret management solution. Then yes, definitely Akeyless is one of them, if not the leading one, if I may. Yeah, so that was my emphasis for now. Back to you, Lior.
Okay, thank you for that. There is another question from Manish. Our company has test and development server in cloud. Do we need to implement all security controls like IDS, IPS, container security in test and dev environment, which is just hosted only a small span of time or for a specific POC purpose? Moshe, I think this question is for you.
Yeah, actually I answered it in real time, but real fast, recapping what I said. Basically, if you have your container runtime solution, for instance, you mentioned IPS, I guess you meant some kind of a container runtime solution. I don't see the great value in the test environment. But if you have container solution, for instance, that checks for malicious images, if you have container solution, for instance, that checks that there is no secrets in the code, those are definitely solutions that are valuable also to the development environment.
Okay, guys, if there is any further question, please write them down in the chat. If not, guys, if you have any, write them down in the chat. If not, we will conclude.
Also, because of the minor gap in the demo, we will send as part of the recording links a recorded demo, so you'll have an idea of how to implement it.
Okay, great. Thank you for that. And of course, thank you all for all the lectures here. Ori, Moshe, Naor, Oded, thank you for your great lecture. All the topics, all the recorded session will be also uploaded to our Meetup group page. So stay tuned to our next Meetup. And thank you all. Thank you all for coming. Have a great evening, a great day in Milwaukee. Hi to everyone, and keep safe, guys. Thank you all. Bye for now.
Everyone.
Thank you, Lior,
Thank you.
for
Take care.
organizing this.
Bye bye.
Thank you,
Thank you,
Lior.
Akeyless. Bye bye.
Take care.
Take care.